So in tutorial 1, we will be going through a few basic things in Python. First of all, like the most basic out of the basic is numpy. And I think most of you should have already some knowledge in it. Then we will go to Xarray, which is a very useful package for opening a netcdf file, which is a very common file format for atmospheric data. And then we will use matplotlib, I think it's matplotlib, what I call it. And we will use this package to create some plots. And I think all of you should be familiar with this already, but yeah, we will still go through this. And then hrplot, you may not heard about this, and we will be creating some interactive plots using this package. So this is what the tutorial will be about. So let's get started. Okay, so first of all, we need to import the necessary libraries. Like this is what should be done. So we just run this cell and then, yeah. So basically we'll go through numpy first, and I hope I will be quick on this one because you should be able to, you should be familiar with this. Okay, so basically numpy is a package that have many operations on the numpy array. So this is really really important package that do operations and maths to your data. So basically, okay, so you can go to this website to browse some of the important functions that is available in numpy. So I'm not going through this. You can go to this by yourself if you're interested. So first of all, we should know about how to create a numpy array first. And there are several methods to create a numpy array. So like this is the most basic form to create a numpy array, which is by this np.array function. Then you just type the elements that you want to be in this array. So this is basically like in row 1, I want the 0, 1, 2 elements, and in row 2, 3, 4, 5, etc., etc. So this is like really the basics. So when you run this line and then print this array out, you can just see this structure. And then there are also many different ways to create a numpy array. For example, you can do this. This is the function that create a 1D array. So when you also run this cell and then print this array, you can see this is like a 1D array with 1 row and 9 columns. And then by calling a function reshape to this B array, then you can change it to a 2D array. And there are also some very important functions that you can initialize an array with the ideal dimension that you want. So basically, I want a 3 by 3 array that is initialized with 0s and 1s. Then I can just use these 2 functions to make it. So you will get a 3 by 3 array with all 0s and a 3 by 3 array with all 1s. Yeah, so this is, okay, so the basics to create the numpy array. And then if you want to check the size of the array, you will have to call the function .size after the array name, okay? So you may want to check the data type of the array. Okay, so basically the type function is a built-in function in Python that shows you what is the type of this particular object. So when you run this line, you will see there is a numpy.end array. So it basically means this variable contains a numpy.end array, and this is the data type of an array. But if you want to check the the data type of the elements in A, then you will call a function dot d type to this array and then run this cell. And then you will see actually the elements in this array is a 46-bit integer. And well, okay, let me introduce what is like a 36. So basically in 64, I'm sorry, 64, it's a 64-bit integer. Yeah. So you may have some other bits like 32, then it will be a 32 integer. Okay. So if you have more bits inside the integer, then it means it can contain more digits. Yeah. So, and you may want to change the data type inside the array. So you can just type as type. Maybe you want to deal with decimal numbers and you don't want this integer type data type. So you just type float. You may want to change it to float, which is called a floating point number. And it helps you to deal with decimal numbers. So you can just change it to float and make it like a 64-bit float number. Yeah. Then you will change the data type of the elements inside this array. So if you call the dtype function to check the data type, it will say that it is a float 64 array data type. Yeah. So after introducing some basic functions and elements in a numpy array, then let's go through about indexing and slicing. So indexing is really simple. Yeah, you should know that. Well, basically you just add a square bracket after your array, then you will call the elements inside the array. So here I just give you a few examples. Like if you call this B array, which we already run it before, it is something like this. Then if you call the first element of the array, then you just press the square bracket and have a 0 inside. So it will call the first element of this array. Yeah, so this is it. And if you call -1, it will call the last element of this array. And then this thing, okay, I should have told you this before. Okay, so we have a indexing rule in numpy. So this is basically the rule of this. So inside a square bracket, if you type index number here, it will indicate what index number you want to start slicing. So basically, if you want to choose like, okay, I want to choose, for example, in here, I want to choose the element starting from the second element. Oh, sorry, the third element, because Python starts from 0. Okay, so if you want to choose the elements inside B that is starting from the third element and then ending at the second last element. And then the third index inside this bracket is the step. So basically it means the steps that you slice the array. So when you run this command, this is the original array B. And then if you run this command, it will show you, okay, I'm starting from the third element as 2, and then I want to choose the element every 2 steps. So it's like 2, 4, 6, and then the last one I don't want it because I have defined it here at the end. So yeah, it will not show the 8 here. So it will choose the 2, 4, 6 by this operator. And then, okay, so the same rules go for 2D array. Yeah, you just need to add a comma to separate the operation to rows and columns. So for example, here you have a 2D array A, which is, okay, 3 by 3, and each row, it has elements like 0, 1, 2, 3, 4, 5, and then 6, 7, 8. And then if you choose the first row of the array, then you just type a 0 in it, and then it will return the first row of the array. And then if you want to specify which row and column you want to choose from the array, then you add a comma to separate the row index and the column index, and then you will it will return your desired element that you want to choose. And then if you put a column here, and then you mark the column index as 0, it means you want to choose the first column. So like 0, 3, 6, yeah. So you may want to apply more indexing rules to choose the elements that you want from the array, yeah. And here, basically it means, so what I introduced before is like an operator square bracket that you can choose elements from it, but actually you can use another representation to do this same thing. So it basically is a slice function. So this slice object behaves very similar to this operator. So it means, because I have told you before, this is like a start, end, and step, the slicing rule. So in this object, you can also define the start, end, and the step indexing. So for example, if you want to choose every 2 steps of the elements in here, you can do it in this way, but of course you can also do it in the slice object, which will be in this form. Okay, so here are more examples. You may want to read it by yourself, right? Yeah, because this is like really the basic things.